Live from El Salvador, my name is Magnus, and welcome to today's Sovryn Tea. Ladies and gentlemen, don't forget that Twitter Spaces are interactive. We will take questions at the end. We always get a lot of questions throughout the space, but at the end, we'll be taking them. So to discuss today, we're going to be joined by John Light. He's a product manager here at Sovryn. Most recently, he's become a ZK Roll-Up Research Fellow with the Human Rights Foundation and Starkware. You can catch him on podcasts such as The Crypto Conversation. We have Ruben Somsen on board. He's a Bitcoin sorcerer who does protocol design in order to enhance Bitcoin. He also helps maintain the Bitcoin dev mailing list and co-hosts the Unhashed podcast. Patrick Dugan, who you just heard from, he's the founder of TradeLayer, a P2P derivatives and hedged currency decentralized exchange on Bitcoin. And of course, last but not least, we have David Seroy. He's a Bitcoin advocate and freedom maximalist. He's an active member of Sovryn's extractor community and a respected contributor to the Sovryn community. So guys, just before we get going here, I wanted to do some Bitcoin jokes with Magnus as an icebreaker to lighten the mood. Here's our joke for today. Terra USD. Thank you. Oh, yeah. Oh, yes. Thank you very much, folks. I'm sticking with my day job. All right, so let's just kick this off. John Light, we have you up here. Can you tell us some of the projects you're working on? What's exciting you at the moment?
Yeah, so you mentioned that I recently started a fellowship at the Human Rights Foundation to investigate whether zero-knowledge proofs, specifically ZK rollups, could be used to improve Bitcoin scalability and privacy. So that's one of the projects. And then there are a few different projects I'm working on at Sovryn. The main one right now is Zero, which is a 0% interest decentralized borrowing protocol and stablecoin backed by Bitcoin collateral, and a few other projects that are in the works. And then I have a few kind of personal projects that I work on. Like I maintain a list of sidechain resources on my GitHub, and also and actively maintaining a guide for running a personal Electrum server on a Bitseed hardware.
Very nice, very nice. And Patrick, since you had the floor a moment ago, would you like to fill us in on anything new and exciting for you at the moment?
Yeah, after about 4.5 years, we're finally putting the derivatives logic in its, we had to kind of go back to the drawing board on the clearing model last year. So it's been a bit of a whiny road. So we're kind of in the home stretch on TradeLayer, and that's kind of big for me. And then I've been working with the Starkware guys lately on, I did a small grant for some articles. Those are in the draft stages. One is about clarity versus Cairo, and the other is kind of a deep dive on all the papers on some of the big ZK protocols on ETH, so keep an eye out for that. I'm going to try to get some feedback on it, do a little more work, and get that publishing. And we've just begun working on this thing called StarkSync with them, where they're sort of branching into Bitcoin a little bit, trying to do good for the community, I guess, and happy to do the work. So we're working in Cairo to take different intermittent chunks of what happens inside the guts of Bitcoin and build proofs for it, and we're trying to get step by step towards doing it for the whole block history, so that you can rely on a proof like that instead of having the data availability of all those gigabytes of history up to some block, right? So that's where we're trying to go with that, and that would be open source, and that's potentially very interesting. So I'm really excited about that.
Yeah, we'll just go to Yago real quick. Yago, can you hear us? Are you online?
I can hear you, yes.
Good, sir. Yes. Anything exciting you in the space right now?
No, it's been an incredibly boring few days.
Yeah, totally.
It just looks like we're finally getting back to a bear market, which is great because it leaves space for conversations like this, and everyone can get back down to thinking and working carefully in peace and quiet again.
It's a good attitude to have.
I
Ruben,
don't
you're
know
here.
about that. I prefer to make more revenue on average each month is better for me, but it's a matter of taste, I think.
Certainly, but bear markets are not time periods that you're unable to grow. What is nice about them is that the growth that you make is sustainable, and you know that it's due to your efforts rather than it's an influx of tourists. But that's what bull markets are for. They're for harvest season. Now we sow so that later we can reap.
Guys, let's start off because the topic of this is ZK proofs in Bitcoin. Let's ask the general question. Would anyone like to answer? For people who are not too familiar, what are ZK proofs? Can you put it in a nutshell for us?
Patrick, do you want to take that one?
Well, they, in a simple sense, involve combinations of constraints where you can get the implication of something that's pretty robust without actually knowing what it is, right? So in practice, that means doing this thing called arithmetization, where you're translating a block of code, for instance, or a block of stack instructions, which is very simplified code. That's the way a lot of these VM architectures that wrap Solidity, that are like on Polygon, for example, they've invested in like 3 of them. They use the stack. So you've got this very clean way of kind of organizing computation. It translates it into this array that gets looped through, and you factor polynomial constraints out of the contours of that array's execution, and then you can test those and get a pretty great confidence level about whether or not it's within the constraints or not. And what that allows you to do is take a whole bunch of computation, including for derivatives trades, such as how StarkX works with DXDY, and spit out one short proof that is very fast to verify. Now, producing it isn't fast, but it's worth it, and you can split it into little recursion dealies, and lots of people in a network can contribute, which is really great. Like back in the old days when we CPU mined like Primecoin and shit coins like that, but maybe more sustainable, right? That obviously wasn't sustainable. And of course, there'll probably be ASICs for some of the stuff in the future too. So yeah, it's a little math fold or several math folds, and then a bunch of other little folds to try to improve performance. That's where a lot of the R&D's gone since about 2020. The Electric Coin Company did a lot of work in this. Starkware did a lot of work. People then build on those foundations and come up with their own things. And there are about, I'm going to say 7 or 8 major approaches on Ethereum so far. But they all generally utilize similar core mechanics of arithmetization, recursive factoring of these proofs. And a lot of them are Snark based, where you have this data inline to it. So Snarks they have lower TPS, they have lower data footprint. Stark is, the acronyms changed because they're emphasizing scale. That's based on the Validium model. You don't have any data availability, and instead you get this fat deal that can basically truncate an entire, theoretically an entire internet's worth of activity. Now that's an exaggeration, but that's kind of the scope that like StarkNet is aiming for. And then on the other side of the spectrum, you've got things like Loopring, which are really neat roll-up designs where Loopring is aggregating a bunch of trade signatures in order to do these little clearing batch auctions, which is a neat way to, as opposed to like order books or peer-to-peer handshakes. It's an interesting model. And because that is so tight, the data is very elegant in that setup. It rolls up very nicely. So Loopring gets some cool points for style, I think. And I guess the major contenders on Ethereum would be like, in my book, would be like Polygon, which has multiple approaches in their stable. They've invested $1 billion into acquiring those teams. And then StarkNet, where Starkware's raised like 100 and some, but definitely contender, because I think they've got a really cool stack. Is kind of the shorthand for why I think there's something more interesting in Cairo as a flexible language. But other people may well do fine writing apps where they have Solidity contracts, and then there are these stack push operations, and they've got to kind of keep a mental model of that in order to set up the core circuitry of what they want to prove. So that's kind of a big answer. Anybody else have like a more concise way of describing it?
Yeah, so I guess I'll do a very brief intro and also answer Patrick's question. So mainly, I think most people here know me, and I'm excited here to talk to some of the people that I've been talking on Twitter to, and now actually talk in voice, so that's nice. So I think it'll be an interesting conversation today. The way I would describe these zero-knowledge proofs or Snarks or Starks or whatever you want to call them is mainly as something that can aggregate witness data non-interactively. And by that, I mean basically, if you send a payment, let's say from Alice to Bob, there's always a part that, at least in Bitcoin terms, we call witness data. And the witness data is basically the thing that says that Alice is indeed allowed to send money to Bob. And the simplest thing you have there is just a signature. And so what you can do with a zero-knowledge proof or with a Snark, let's say, is that you can take a whole block, and you can take all these witnesses, you can take all these signatures, or it can be more complex. It can be something like a trade or something where Alice is offering money if somebody else pays Alice a certain amount. That's transition that it actually happened, and that it actually happened according to the rules, that can basically be compressed, that can be non-interactively aggregated and compressed into a single bit of data that is then relatively cheaply verifiable. So really, that is kind of the main thing that Snarks or zero-knowledge proofs do.
That definition kind of misses a couple of important elements. One is the privacy possibility of zero-knowledge proofs. So if you're talking about zero-knowledge proofs in a scalability context, maybe your definition comes close, but it does miss on the privacy potential. But even in the scalability potential, I think an important distinction between just simply aggregating signatures versus what zero-knowledge proofs provide is that even if you do signature aggregation, full nodes still need to maintain the UTXO set, update the UTXO set, replay transactions, and that all puts computational load on the nodes, and also it takes up disk space, etc. Whereas with, say, a ZK rollup, the full nodes don't actually need to replay any of the transactions that happen on the side on the rollup. They just need to verify the proof in order to allow the sequencer to kind of update the state of the rollup on the main chain. So this saves a bunch of resources that I don't think simply aggregating signatures can accomplish.
Yeah, no, I mean, I agree with what you said, basically. And I think, personally, it fits within that description. Because the thing with privacy is basically, what I described here is saying Alice sends money to Bob, but that link is also gone. That's also a witness, that it's specifically Alice sending to Bob. And instead, it can be, Alice, it can be a bunch of people paying a bunch of other people. And the link itself is basically also witness data, so that also can disappear depending on how you do it. If you do it naively, then the problem you get is that the person who creates the Snark will know the link. So you actually need some kind of system where the person, when you make the payment, you also want the person creating the Snark to actually not know that. So that's sort of a secondary thing there in terms of complexity. And then I think, what you can do with those Snarks, one of the implementations is a ZK rollup, but that is more than a Snark. And I agree with you there that you get some interesting benefits in terms of having this other chain of which basically only the people who are actively using it, or well, not even actually, if the Snark runs as without any hitches. But yeah, you don't have to keep track of the state yourself. So that's definitely a nice benefit. I agree with that.
Ruben, you wrote recently a very interesting thread. Maybe we can link to it here, arguing that because we would be compressing witness data, we would only basically get 50% improvement in scaling in Bitcoin. Yep. That seems to be different from what you've just argued, which is that a roll-up would allow effectively aggregation of multiple different transactions to multiple different parties, where the important information is occurring and the transactional information is occurring on the sidechain. So I'd be interested to understand the difference that you see between those two claims.
Yeah, I don't see a contradiction in what I said. So I'm not sure where the disconnect is here. But so I think it's good to sort of like we're already getting into the weeds now. So let me at least set the stage a little bit and say that you have multiple versions of these rollups, and that's kind of what we're talking about now. So we're not just talking about adding, taking a regular blockchain and then putting a Snark on top to compress everything, but we're saying no, let's have a sidechain, let's have a ZK rollup, and do it that way. And doing the ZK rollup also has sort of, let's say, two versions. I mean, you can put it in any category you like, but one version is that you basically create this other chain and you make this chain as small as possible because you apply the Snarks to it. And then you put what's left, you put all of that onto the main chain. And so when you do that, you're still left with the non-witness data. So you're still left with Alice and Bob, but not the in-between, not the signatures, not the complex smart contracts. So all of that is gone, but you still need to know, you still need to put on the main chain that the Alice had some money and now no longer has that money, and now Bob has that money. And so then there's this second set of use cases for Snarks where people try to also keep that data off-chain. And when you do that, you start to have these certain trade-offs that we can certainly discuss, and we probably will be discussing in this conversation. And so I think those trade-offs can be okay depending on what you want. But specifically to my 2x claim, that was a claim regarding still needing to put that Alice and Bob data onto the main chain. So even if you have the Bitcoin blockchain, let's say, and you have these ZK rollups, still you need to put the non-witness data of these ZK rollups onto the Bitcoin blockchain, and that takes up space. And because that takes up space, and because we know, at least from the Bitcoin blockchains, in that case, we know that half the data on the Bitcoin blockchain is witness data, half the data is non-witness data. Unless you rearrange that non-witness data in a way that is more efficient, which is also interesting to talk about. But if you don't do that, then at most you end up saving 2x. Is that at least clear, Yago?
Yes, I think I think it helps set the tone, sort of set the scene for the conversation that I expect will come now.
Well, I think I can maybe clarify it even more, because basically it's not a silver bullet. You can't just have a thing verifying as being true, push Bitcoin. We still lack this functionality. So you can push Bitcoin on a sidechain. You can push Bitcoin with a new opcode activation, which is a long, big process that I'm not trying to prosecute myself. Right? I've always been looking for other avenues. That's why I like op return stuff. It's provably prunable. You can do these other tokens. People don't value those tokens as money as much as they do UTXO Bitcoin, and that's fine. But they can do more things. And then maybe you could have an inline verifier logic that would then do some kind of batch settlement. And for that, a rollup is probably better than a Validium, because you wouldn't, the DA problem is there. How do you get them in? You do like a soft fork, so you can just pass around these fat op returns, but it's going to be expensive. You can have a URI to another data availability oriented platform. There are several of these: Filecoin, Arweave, Celestia is hot, I hear. So I expect people will do that. It's like Veriblock. If anyone remembers Veriblock from 2018, it was a big part of the block usage. That was Jeff Garzick's thing, and it was like have your shitcoin make an op return periodically, so it'll be secured by Bitcoin through a checkpoint. So I mean that's worth something. They were paying for it, right? But that was like a limited idea, right? So we have to basically make some kind of compromise. There may be possibly a way to come up with something clever that's like Lightning Network oriented, but I don't see how a verifier is going to fit into that, right? So these are the kind of like trying to push Bitcoin is like basically the grail of Bitcoin protocol development, and yet the thing that you're not allowed to just get because we haven't figured it out yet as a community, I think is the diplomatic way to put it. Would you guys say that's accurate? Also, like the peg in, peg out figures into this problem, right? How do you settle the peg out in a consistent way, right? Any thoughts on that?
Well, where I'm coming to this from is with a particular agenda. My sense is that one of the things that we don't really talk about in Bitcoin, but that we probably should be, is how do we get Bitcoin to be code complete? Ideally, Bitcoin wouldn't introduce any further changes. It would become basically a law of nature. And I think that the only way that we can get there is if we have a viable path to being able to introduce new types of functionality and new types of behavior external to, changes to main chain. And so one path that seems viable to doing that is to have a system where you could have a whole slew of different functionalities, and they would be introduced through zero knowledge proofs only in terms of the ultimate transactions in Bitcoin that should be occurring to main chain. One of the things that Paul Stock has spoken a lot about is sort of BIP 300, his proposal, sidechain proposal and pegging proposal, to use his proposal drive chain as like the last change we need to introduce to Bitcoin. I'd like this idea of having the last change that we need to introduce to Bitcoin. I'm less convinced that drive chain is the way to get there.
Drive chains were a little sus personally, but I know some people swear by them. Go ahead.
Yeah, no, I mean, I think it's an interesting point. Like with drive chains, the problem is really that you're trusting the miners not to steal, and that is kind of the painful thing there. But in terms of how we're going to get there, right? Like, Yago, I like your kind of setup of saying like, okay, well, we want basically sort of a more flexible base layer that allows us to do everything that we want, and then create these other layers after that. And have most of the pressure kind of be on there. And I'm not sure if I think that these Snarks or zero knowledge proofs are sort of going to be that base layer necessarily. I think it would be more interesting to have something along the lines of simplicity, where you have a smart contracting language that is basically flexible enough to allow you to implement zero knowledge proofs. And then you can use those zero knowledge proofs to then create your secondary layers, etc. I think that is going to take a lot of engineering to do it correctly. And you could say like Ethereum is already there, right? I think where Ethereum is interesting if we can do it in a safe and scalable way. And the Ethereum method there is kind of more haphazard and let's just do it, let's just get there now. And that is obviously not really suitable for Bitcoin. But I do think it's nice to have all that flexibility and have all those features.
Have you looked at Clarity at all versus Simplicity? You have any thoughts? Just a quick sidebar.
No, I have not looked at Clarity. I'm not a big Stacks fan, as you might have guessed.
Sure.
Just to clarify, Clarity is the non-Turing complete smart contract language that is used and has been developed by Stacks.
Correct.
Yeah, I mean, it might, I haven't looked at it, and might be interesting and viable too. And so maybe it's just analogous to adding simplicity. I have no strong opinion on that, basically.
I would say so. And Munib was teasing, how everybody in this industry loves to do announcements of announcements because they're feeling giddy. Ooh, I can't wait. Guess what's I'm going to drop in like a week, Anyway, so he's teasing us with that. But the other issue is like trying to get the thing to write to Bitcoin, which could potentially solve this much simpler than anything needing ZK proofs necessarily. It's a way of doing peg out without trust based on Clarity VM. So anyway, we can look forward to that. I'm imagining you're going to have something like a multi-sig, which gets reused. So it's like an HD kind of cleanliness of address, non-reuse, right? So it's kind of like BitMax, right? They would reuse it, but eventually they stopped doing that. They just gen you a new one. So then you maybe have a smart contract wrap the control of that key. There's still theoretically some risk, but if you haven't spent it yet, it's like more quantum secure. So it couldn't be too bad. And like a crappier version of that would be like using something like RWeep to can some JavaScript, and then it's still pointing at an RPC node, and maybe it could do a bunch of queries and make sense of that in JavaScript. It's imperfect. There's still these central points of failure in the automation around, everything's based on keys as atoms. You don't just do a stack operate. I mean, so with the original Bitcoin VM, you do, right? And when you like have some solidity and you write a line of it and it moves a register value, like by moving like the simple send, right? That's in the EVM, it's that model, right? So that they've got the VM. And obviously we want better VMs, right? And then as far as the programming goes, I quite like it. I'll have to look at Solidity actually, and I might not do a whole article about it, but I'll definitely compare it because I'm really curious. And of course, I got put off from from Simplicity just because of like tribal radiation energy, right? Which is, I think a lot of people are influenced by these sort of social factors, and then we don't research certain things, and that's not the best science, right? So it's good to go read everyone's papers and stuff. And then the main difference between Cairo and these guys is that it is Turing complete. It has to be Turing complete essentially because the arithmetization is basically like a Turing machine, like in flow, right? And it's kind of like assembly. So you actually go deeper. Clarity is a bit simpler to resolve and look at. And I imagine Simplicity is. That's why the name is like that, right? Is Simplicity a Lisp? Is that it's like a functional language, right?
I mean, I think it's going a little bit off topic to go into Simplicity in its entirety, but it's basically regardless of the exact details, it's basically a way to get better, like more advanced smart contracts into Bitcoin. And the key factor there is sort of that you have this very simple language that you can express anything in, but the way you express it is sort of not very efficient. But then you can soft fork in the equivalent code that is more efficient for everybody to run. So basically, while you can theoretically do everything with a few simple instructions, in practice it's not efficient enough. But because you already have all the capacity to do everything, it's easy to make the argument that you add it into Bitcoin as a soft fork that does the same thing, but just more efficiently.
Well, and I think that's how it's going to flow. Is we're going to see these weird compromises, and people take a little extra risk, or they, it's slower, more expensive, or some of these different trade-offs. And then eventually there will be some sort of technical consensus about what's the clean, safe way to streamline what's the most popular. Probably is how it's gonna be kind of a democracy of fee revenue is how I foresee this plan for Bitcoin. But Edan, I don't necessarily agree that we have to do like one last hard code and then occupy forever. Of course, that would solve the dilemma of what's the true nature of Bitcoin. But I'm just saying, like, we can do compromised versions now with op return, which was meant to just be, of course, like the return statement in code, right? It was meant to just be the catch-all for the original VM design. And now what we do is we just put data in it, and then we have, you like interpolate from that data the state of tokens and contracts and things. So it's not the most, you guys are working in Tendermint with, I think like an EVM base. Is that right?
If by we you mean the Sovryn. Yes, the Sovryn's built on Rootstock, which is a EVM compatible sidechain, which is merge mined with Bitcoin and is much more similar to Ethereum than to Tendermint. So especially with the proof of work merge mining. But I think you bring up a really interesting point, and maybe it provides us with two different avenues that we can explore. So I think there's an incrementalist approach, which Sovryn is taking, and Blockstream are taking with their sidechain, and Munib is taking with his sidechain, and you're taking with UpReturn. Where, all right, we've got a bunch of different tools. We're going to have to make compromises because base layer doesn't provide us with what we want right now, and over time. We can incrementally move towards where we would like to be, which is hopefully, very few compromises, if any, and sort of have cryptographic assurances of what we're doing rather than trusted assurances. And then there's the other approach, which is sort of we can introduce a change to a Bitcoin main chain, which allows us to take all of our experiments off-chain, and then maybe we're still incremental, but at least to the extent that we're interacting with main chain, we're doing so in a cryptographically trustless way. Unquestionably, in terms of reality, where we are right now is all of us are experimenting with different incrementalist approaches. But maybe one way to frame this conversation is for us to compare some of those incremental approaches and where they may lead us to, and then also try to think like on between us what our view is on what the simplest sort of end state. If we could snap our fingers and make any change to Bitcoin, do we have a view to what that change might be? David, you also had a recent conversation that I saw on Twitter around CTV and how it might provide a path towards introducing improved pegs, some more trustless pegs and more trustless ways to work with sidechains. Is that something you'd like to speak to? I haven't been able to find it. I wanted to try and link to it here, but I haven't been able to discover where it was.
I actually don't recall that. It might have been something I posted or kind of that piqued my interest on Twitter, but I can't remember exactly what you're referring to.
Okay, fair enough. So how do you guys feel about sort of framing the conversation in terms of incrementalist approaches versus what our ideal approach would be?
I was actually going to try and steer it back to specifically talking about ZKtech, because I think we're kind of veering into like Bitcoin, I don't know, governance or kind of like big picture vision stuff. But
fair enough.
I think that's fair enough. Yes, I was thinking about ZK both in terms of its incremental potential and its maybe its ideal potential, but and sort of that's the way I'm thinking it in my mind. But you're right.
Okay.
But how would you think? So in terms of your perspective, what do you see as the most promising aspects or the parts that you find most exciting about ZK? And do you see? And in your mind, do you have like more incremental things, or is there just only an ideal path?
Well, from my perspective, there are like ways to use zero knowledge proofs in Bitcoin today, just like not on chain. So Wabi Sabi is a privacy protocol that's used in Wasabi 2.0, and they use zero knowledge proofs to support their kind of like arbitrary amount coin join protocol. There's a protocol called ZK channels that was developed by a company called Bolt Labs, which is like a layer 2 payment protocol that adds privacy so that the recipient of a payment doesn't know like which channel that they have open actually sent them the payment. So it like hides the sender identity. So there are, you could call them incremental approaches to like adding zero knowledge proofs to Bitcoin. In terms of like more advanced usages, I'm particularly interested in using zero knowledge proofs for privacy and scalability. So like getting full kind of on-chain privacy for being able to hide the sender, recipient, and amount of transactions, similar to the like how Zcash's privacy protocol works. And then for scalability, ZK rollups are interesting. And I'm excited about the research that I'm doing there. But there's also like approaches like what Coda, or I think they're called Mina, is working on, where they use zero knowledge proofs to actually compress the entire blockchain down into like a 20 kilobyte proof. So that like basically a full node that is coming online, all it needs to do is download this 20 kilobyte proof, and it can be convinced that the entire blockchain up until the current chain tip is valid. And I think that is really interesting and could help with scalability.
Valid but not available. I just want to interject, but go ahead. Yeah.
No, but it's a roll up. So Mina is actually optimized for like the most network fecundity that you could get for marginal participants. That's what they've optimized for. So every transaction that gets in a queue, it's like it's a real conveyor. It's a real roll up in that sense. There's this assembly line process. And so it's continuously maintaining that length. And I guess, I'd have to look into more details about how the date of availability is going to translate in a wallet app to a verified balance, right, with specific values. I'd be curious to learn more about Mina in that way. But I was very impressed by how they went all in that direction of just all the strengths of Snarks, which are kind of more light. They're like the Zerglings of ZKs is how I like to think of them.
Yeah, I mean, I don't think the data availability problem for Mina is any different than like Bitcoin. Like, if the miners don't broadcast their blocks, like, yeah, you're kind of fucked. But you also don't accept the transaction is valid until you can actually know that you can spend the coins.
Right. John, what do you think about, just real quick, what do you think about the potential of ZKs helping voting technology to be both, corruption proof, but also you can't, you shouldn't have voted, like we're protecting the privacy of, especially in a politically contested country where people are at risk, right?
I mean, I think that there's some potential there. There's some online voting software called Helios that uses zero knowledge proofs to do like private voting. I don't know if it's resistant to like bribery or collusion. That's where you get into some of the work that Vitalik and Barry Whitehat and some others over at the Ethereum Foundation have been working on for bribery and collusion resistant private voting. I would say I'm generally skeptical of high stakes electronic voting.
So I want to sort of bring it back to John, what you were saying earlier. I think you made some interesting points, and I think it's something we can kind of continue on. So first, you gave a few examples of zero knowledge proofs like Wabi Sabi, and I'm sort of realizing that I took this conversation to mean Snarks, but a zero knowledge proof, like even a signature is a zero knowledge proof. So I'm not sure if this, if the conversation here, like how broad we want to make the conversation, but you're right. The
signature isn't technically a zero knowledge proof. Sorry to cut you off, but there's a difference because you have to reveal some information to the verifier. It's not technically a zero knowledge proof according to the like academic definition of the term.
I mean, from what I understand, I mean, maybe you're right, but from what I understand, it is because like you're reveal with zero knowledge, like without revealing anything, you're proving that you know the private key basically. But sure, I mean, definition.
You reveal the signature, which
you reveal the signature,
reveals that you own the private key.
Yeah, but you don't reveal the private key itself, is what I'm saying. So in that sense, it can be seen as well, but it doesn't really matter. I mean, it's a definition, right? So sure. But you took Wabi Sabi as an example, and Wabi Sabi is certainly not a snark. So we can take that as an example if you prefer that. But
no,
I think
but I mean, like they actually use like zero knowledge proofs, like so the client is generating zero knowledge proofs to prove to the server that the Peterson commitments that they're providing are valid, without revealing any other information about the transactions. Yeah. It's like literally a zero knowledge proof that the client is using for the server.
Yeah, no, I agree. It's a zero knowledge proof, but it's not a snark, right? So that's what I'm saying. Like they're all zero knowledge proofs, and I'm just saying that I thought this conversation was going to be more on the snark side of things, but I agree with you that we can take it more broadly, and that it's interesting too. But the other thing that you were saying that I thought was interesting, John, is you said you're interested in privacy and scalability, and the thing that I'm sort of thinking of right now is that those two sort of kind of go together, because the less you reveal, the more private you are, and the less you reveal, the smaller the data set is basically. So I think there's actually a very nice opportunity there to sort of try and do both. But the side that I'm concerned of, and I don't know, John, if you have looked into this or no, because I think you're more knowledgeable about sort of like all the stuff that's out there currently. But I was alluding to it earlier. But in order for you to be private against the person who's creating the snark or who's creating the zero knowledge proof, you also don't want to reveal to them who you're paying. And the only way to do that is to send them a zero knowledge proof in the first place. And so that adds, instead of having all the complexity be with the person who's creating the snark, now on the client side, you also have this extra complexity of having to create a zero knowledge proof and having to send that to the snark creator. And that seems to me like something that could at least make it harder than the sort of naive snark. And I'm wondering if you have an opinion on that.
Yeah, so using Zcash as an example, all of the zero knowledge proofs that users are creating to protect their privacy are done by the user themselves, on their phone or on their desktop computer. And they've got the efficiency of this down so that they're generating these proofs within a couple of seconds. It's not really noticeable to the user anymore. It used to take, a couple of minutes on a desktop computer, but now they've gotten it down to just a couple of seconds.
And maybe, so specific to Zcash, do they still use a trusted setup or have they moved away from that now?
Currently they do. They're implementing a change to a hard fork in the next month or two that will remove the trusted setup requirement.
Okay. Oh yeah, that's nice, because at least what I've seen, and I think the space is moving rapidly and we're seeing improvements going really fast. But one of the concerns in the past, at least, has been that the trusted setup zero knowledge proofs were faster than the non-trusted setup ones. And I think, and at least hope, that we're sort of moving away from that. So that would be nice.
Yeah, we are. I mean, that's the whole point of Starks, right? That you get away from the trusted setup, it's quantum secure, and then it's theoretically, you get this log scale. Well, it's not theoretical, it's demonstrated. You get a log scale, the more you add, it gives you a payoff, whereas ZK Snarks generally top out about 2K TPS, which is probably decent, but if you want to really aggregate beyond just one app. So Snarks can be good for apps because if you're very delicate canonical core data, you might be able to roll it up easily that way. Privacy fits in too.
Sorry, Patrick, something maybe you can also respond to is, so you're giving the example, and Starks are a good example, that where if you aggregate a lot of data, it's very efficient. But the example that we're talking about currently, or at least the example that I gave, was that the user has to prove a statement to the person who ends up sort of compressing all the statements together. So that final compressing of all the statements, that is certainly going to be efficient. But for the user to individually create their own proof and send it to the Snark prover, that part might not be so efficient in the case of Stark.
Well, that's the beauty of recursion, right? So Halo was Electric Coin Company, which is a Snark-based approach. There's Plonk, and there's FRI, which is Fast Read Solomon Interactive. So, like, Starkware guys did particularly is they leaned into this direction and they saw, okay, there's this valley of trade-off, and if we could just win, if we could just get massive scale, then we'll get to this other side and it'll be great, right? And then in addition to that, they went with the Validium. You're kind of trusting them to keep the data availability, which is going to get belayed out to all of the StarkNet users, and then eventually the StarkNet users running an alternative ETH client, the same way that like TradeLayer, not exactly the same way, but in a somewhat analogous way, that TradeLayer is an alternative client for Bitcoin, Litecoin, and it's collating this other stuff. And so what I'm envisioning is you're going to have these JavaScript Bitcoin clients where maybe the UTXO set and the historical data can be inferred by proof. So you get a much lighter thing. You can run it on a phone. It's going to make things easier to develop like alternative layer logic that's all in JavaScript. I could see that. Or bridges to stuff that are more flexible. The other thing that I think maybe we'll address is like data availability within Bitcoin. Like if you think about just basic Bitcoin wallet development, it's a huge pain in the butt, and you end up relaying to some API to save yourself a little, because Bitcoin RPC calls are naively replaying all of the block history in order to write into LevelDB things that we take for granted. RPC calls, like what are my balances? What are my historical transactions, right? It's got to loop through everything and come up with that. There's no easy like lookup that is out of the box, right? So blockchain.com, for example, is an API most people would maybe use for that. There are other ones, and they've done that work, and you get a big blob of JSON from them, and someone had to develop the code to like ... put that JSON out, right? And it's unfortunate Bitcoin core devs haven't tightened that up. But also in general, reliance on LevelDB is a major bottleneck for client performance. And if you went like Gonzo with Opportune, it would also be annoying. Look at what happened with Ethereum full archival nodes, right? The difference between technically a full node on ETH and a full archival node, several terabytes. It's a lot of data. Rick Dudley's whole startup focus, I guess, is trying to improve LevelDB so that you can get around some of the DA bottlenecks within Ethereum. So this is a problem for Bitcoin too, as we add statefulness and whatnot. And it's really annoying with tracking UTXOs. So what if we had these intermediate proofs for some of these things? It might facilitate a truly light client where you can get a lot of the benefits without all this overhead. And I wanted to mention, since I'm just knocking out bullet points, I want to make sure that they get out there. Your work, Ruben, for collating UTXO state data is really interesting and potentially could be further snarkified. Do you have any comments on that or the LevelDB thing? I'd love to hear it.
Okay, well, you certainly have been going all over the place here, and I'm not sure if you answered my question, but that's all right. So I'm not sure which of my work you're talking about. Are you talking about space chains or soft? Sorry?
Utrixo, I think is how you would say it.
Utrixo. Okay, Utrixo is not my work, but I've done. I have a protocol called soft chains that sort of takes advantage of Utrixo, and so. With Utrixo, what you basically get is it's a compression of the UTXO sets, where instead of keeping the entire UTXO set, you just keep an accumulator that represents the UTXO sets. And every time a block comes in, you basically get all the proofs that are related to the UTXOs that are being spent, and those proofs are then also sufficient to, together with the block itself, to update that accumulator. And so from block to block, all you're doing is basically a single accumulator, or it's actually a couple of hashes, but that's a detail. and you just update it every time. And so your entire state of the Bitcoin blockchain ends up being a single hash. And that's also sort of the thing that ZK rollups sort of end up doing incidentally, because that is sort of how you get state onto the Bitcoin, onto the main chain, whatever main chain that is. And then if you ever want to peg out, if the Snark stops functioning or the chain halts, then you can always peg out from that accumulator and proving inclusion. So that's basically also what Utreexo does. I don't think, I think these are sort of, it's interesting how all of these things are useful both without and with Snarks. So that's kind of cool. Where in Bitcoin, right, obviously we're
Yours is not a zero knowledge. The Utreexo proof and what you use, was it space chains or soft chains? I got to look it up afterwards.
Soft chains in this case, yeah.
Okay, cool. I'm gonna look it up. That has some amount of knowledge incipient to it.
Knowledge? What do you mean?
Well, it's not technically a zero knowledge proof. What Utreexo is.
Oh yeah. Okay, yeah. Sorry, yeah. I get it. Yeah. No, that's right.
Neither is like the SPV header proofs that like Prestwich did when he got those ETH transactions to fire off, right? Like, yeah, you don't have to go. I think the hype is going to make people go, oh, this is a big hammer, including myself. I went through it. That's why I'm going over all these possible use cases. But it's true that you could do other things that aren't necessarily Snarks, and there may be a lot of performance optimization and choosing other approaches, right? To get,
And it reminds me of one other comparison that I sent out a tweet asking people for what they wanted us to talk about. And one person said, could you compare ZK rollups with a Mimblewimble extension block? And I think that's actually sort of an interesting point, because like Mimblewimble uses none of this advanced Snark stuff, but it ends up looking very similar to to kind of what you end up with Snarks, except in a very different way.
I'm geeking out a little bit. Well, the whole point of ZK proofs is you have these polynomial constraints where something equals zero, and then you can you're either coloring within the lines or you're not. That's probably the dumbest / smart way I could try to summarize it. And that is what Mimblewimble is essentially, but without arithmetization and such, or polynomial testing.
Yeah, but it's not a coincidence, right? Like, I mean, in a way it is, but it's also not, because this is sort of like, well, that's how you end up doing it, and these are sort of two very different methods that end up looking the same if you sort of look at the individual parts of it, and that is really cool. I agree with you there.
So I think that beyond L2 functions and possible opt codes to ensconce them as canon, there's just a lot of souping up to do as far as like the UTXO set, maybe not using ZK proofs, but definitely like ZK proofs have a lot to do in helping with the block history, because that's a big old data footprint, right? So if we can just nip that in the bud, it's going to open up a lot of people to using Bitcoin. And then there are some wonky things like how engineers interact with data that is inferential, but it creates this big footprint. That's the level DB stuff that maybe you don't need ZKs to prove some of those, but it fits in with what I'm shooting for with doing it with the history. So, I mean, I'm seeing that all of the advantages of Bitcoin, like there's the smart contract functionality we want to extend some way to get, people want to use those apps. We don't want to destroy the money. We don't want to destroy the core value. That's one side. Just factoring that out, like the whole block size war was about, we didn't have Schnorr signatures yet. So we didn't have linear time, scaling of like, choking on those blocks. So bigger blocks take, multiples more time, and then you get orphan blocks. Can't do it, guys. Okay, makes sense. Now we have Schnorr. I'm not a big blocker, by the way, but I'm just saying that argument now has been solved. And then the other one is that we need people to be able to run full nodes so we can keep the free world free. Anybody can run it on a retail laptop. And what I'm saying is let's have it where anyone can run it on an Android. You're still going to have a place for the full archival nodes who are, dealing with more hardware. They have the data availability, and it's a more efficient sort of internet of value where the heavy metal is in the background producing proofs. Also, people are going to be able to make money from proofs. I think whatever, and then as you add L2 revenue generating, derivatives exchanges is the business model that comes to mind. There's some others, right? And then they're paying fees on chain to plunk back in. Then there's an incentive to distribute some of that value with the node operators who are participating in the recursive proof generation. And that will be like double revenue for miners and a revenue for full node operators that doesn't really exist sustainably today. And I think that's very good. And then that incentivizes people to invest in bits of hardware and really, mesh nets, all that shit. I think this really helps propagate that world. Edan, what do you think about that? I'm sure you have a big vision here. I'd love to hear more about it.
Well, I was going to propose, I think we've been doing a good job of geeking out across a large spectrum of things, but I think maybe the conversation could benefit from going a little bit deeper. And one way that I would suggest doing that is, what do we think are the points of disagreement we have? And maybe it's worth exploring those.
Like as a Bitcoin community, or just the just us guys?
No, just amongst us. And I'm gonna try and stay out of it and more try and act as a host rather than an opinionated. We have enough opinions as it is.
Well, basically, I'm a liberal and I don't like asking permission. So I would rather. And also, I'm like leading one of the least funded projects that is actually shipping, which is the whole thing. And that has made me emphasize, elegance and just trying to get costs down and eliminate waste in the derivatives trading, which to me is everything because I'm a Bitcoin dollarization guy. So to me, like for instance, with TradeLayer, you co-sign these trades, you roll them up into an L3 so you can batch settle it. Like we don't have that yet, right? I need to raise some money or something and get some more guys to build that, put a verifier in the client, right? And then that would achieve what I think would more or less look like maybe the ideal compromise. And I don't want to piss off Bitcoiners. I like Litecoin because Litecoiners aren't as conservative, and that helps Litecoin because it differentiates Litecoin, and Bitcoin's value is in being conservative. So I respect that. And that's why I like being over here. I'm a little unorthodox. But yeah, like if we could do one opcode that would just push like one way to do it would be to redeemably wrap it in tokens and there's a token layer, but then it's like, oh, that's like Patrick Dugan's interpretation of Bitcoin. So probably the thing that's going to be the most elegant for everybody's taste is if you factor out a lot of the who, what, when, and just the where is kind of the crux of it. And then there's like a built-in verifier and there's an op Stark and, or Snark, because you want to know what's actually being proven as well, right? And then so that the thing can just natively push Bitcoin, right? And then whatever you want to layer in between those settlements is the thing. So it's just about that. I think that I want to get people using. I want to rethink Bitcoin clients, and I want to rethink what's possible at the soft fork level. So, really start a movement with this, get people earning money, doing the proving. Obviously, DeFi liquidity providing is a proven business model to bootstrap these things. So I'm interested in that. I guess, yeah, I think other people are more orthodox. I'd love to hear some orthodox opinions.
Yeah, I'm going to try maybe just asking some very like layman's questions. I'm the least technical and probably the least qualified to be up here on this stage. But I think a lot of us kind of, layman people hear this like the zero knowledge ZK, like it can help scale Bitcoin, right? Whether that's on the base layer or via sidechain. So I'd maybe like to focus the conversation on that. And then a lot of the threads that Ruben has commented on, which I'm very thankful that he's interacted with me on, is kind of discussing these trade-offs of why it's not as scalable for Bitcoin as we think. And then if we do make these these decisions to add ZK in some capacity, that there are a bunch of trade-offs that we're taking. So maybe if we can find the conversation onto that, I'd be kind of curious. John, Ruben, maybe you guys have thoughts on that?
Yeah, of course, I have many thoughts. So I think just very generally, and so this is a thread that I linked, and it's also pinned currently on my Twitter profile. I will probably unpin it again tomorrow, but if anyone wants to see it, you can find it there. I think there's this sort of thinking going on where people are saying like, oh, look, we just need to get this one opcode, and Patrick, also the way you're sort of saying it, right, where it's like, okay, well, if we just had Stark, this one tiny change, then we could get to 100x scaling, and everybody could do anything they want, and it's so simple. We're just one opcode away, and this is really a straw man, right? So I know I'm not making the strong case here, and I'm sure Patrick wouldn't put it like this either. But I do think that's sort of a sentiment that is floating around on Twitter, and that is sort of what my threat was against. And generally, I'm also I'm optimistic about this tech, and I think it's really cool. But as a tech guy, like I tend to look at the limitations, right? I try to look at where does this stop working, like up until where can we actually use it, and I think that conversation tends to sort of fall to the wayside, and I think that's also sort of the type of crowd that this kind of ZK stuff, it appeals to the people that want the new thing, and I think those people tend to not appreciate the limitations as much. So that is sort of always what I'm hammering on, and then maybe I get sort of put into this corner of Ruben hates Snarks, or he hates zero-knowledge proofs, or he thinks this is terrible. But like it's kind of the opposite. It's like I think this is really cool tech, but we got to be conservative. We got to be careful, and yeah. So I have been butting heads there, and John, I want to give you an opportunity to sort of like push back on the things I've been saying, because I think rightfully in some aspects you and Eric Wall have pushed back, and certainly some of those points, like for instance the point that I make that like the non-witness data cannot be so easily compressed, like the privacy aspect of that sort of might mitigate that to some degree. And then I think that sort of the second thing that is a large point of disagreement, or rather, I think is sort of hand-waved, is that yes, you can make these trade-offs where you only put the snark on the Bitcoin blockchain and you leave out everything else. But when you do that, you make certain trade-offs. And I'm okay with those trade-offs, but I do want those trade-offs to be clear. And I think a lot of people, like what I'm worried about is that a lot of people, they think, oh, those trade-offs are nothing, or we can just hand wave them and it's not so bad. But a lot of the cases, it's sort of, it's about as bad as a federated sidechain. And we already have those. We already have those trade-offs. So that's sort of fundamentally, like if you're going to add snarks to Bitcoin, and you're ending up with a system that is fundamentally as secure as a federated sidechain, then you haven't really added snarks to Bitcoin for a very good reason. So that's sort of my high-level thinking. And John, please do a good job criticizing my thoughts.
Sure, I'll try. But yeah, thanks for setting the good setup. So on the last point, I would say that if you relax your data availability assumptions, then you do get a system that I think is fundamentally better than anything that you can do with Bitcoin today. In particular, you get a system where the quote unquote federation could like freeze your coins, but they couldn't steal your coins. Which is not the case with federations today, where they have the ability to both freeze and steal your coins. And so I think that's like a noteworthy improvement. And then to your assertions about the like amount of scale that we can eke out of ZK rollups, if you put the data on chain, I think your assertion seems like correct to me in a if you say that we're compressing transaction data of like the existing within the existing Bitcoin blocks. Then yes, because of you're just stripping out the signatures and like aggregating them into one zero-knowledge proof. you might end up only being able to fit twice as many transactions or something like that into the current Bitcoin block. But I think that I think that what you could do is you could propose something kind of like SegWit, where you have this, I don't know, sidecar block that you append to the current Bitcoin blocks, and you would just stuff all of the data in there. And because you don't actually have to replay those transactions, you're adding data storage costs to full nodes, but you're not actually adding computational verification costs to the full nodes, because all they have to do is verify the proofs, which are very fast and efficient to verify. So I think you can actually get a better than 2x or 50% scalability using a ZK rollup if you accept higher data storage costs full nodes.
Oh, yeah, that's actually interesting, because something you said in the beginning of the conversation is that it is possible for everybody on the main chain to sort of ignore the ZK rollups. And so from the perspective of a main chain user, that data, that non-witness data that goes onto the Bitcoin blockchain, it's actually witness data to them, because they don't have to process it. It's only important for the people that are using that sidechain, but they do have to have it in order to know that it's available. And so today we already have this case where witness data is discounted in Bitcoin. So theoretically, if you added something, if you added Snarks and they became really popular, and 90% of the blockchain was Snark data, then this would probably be counted as witness data, and Bitcoin blocks could be as large as almost 4 megabytes within the current limits even. And then you could stretch it out further, which is sort of like your secondary points. I'm not sure if that would be a soft fork anymore, because we already sort of stretched the limits. Can we do that twice? I would have to think about that. But for sake of the argument, let's say we can.
You can do extension blocks, right? Extension blocks can be arbitrary in size.
Yeah. Yeah, I guess, you can, technically you can do everything as a soft fork. The question is sort of is that a soft fork that people find acceptable? Maybe that would be the question, but yes. But the sort of the second concern there that I have is okay, well, let's say I'm wrong about the 2x. Let's say it's 8x, or maybe it's even 16x. Is that enough to justify the significant changes that are required to Bitcoin? I think at 16x, maybe I'm tempted to be more lenient towards it, but at 8x even, I would still say well, that is not really, we could also increase the Bitcoin, the block size by 8x, and that would also sort of be a risk but manageable. But at least from a technical perspective, it would add less. There's a lot that needs to be added, and that kind of goes to my point earlier of saying okay, well, the op Stark thing is actually secretly it is entire programming language that you're introducing. You're just hiding it under a single opcode that then goes and takes a bunch of data and interprets it in a certain way. But that's a ton of complexity there. And then you have to deal with sort of well, how do we put that data onto the Bitcoin blockchain? So you need more witness data. It's not impossible, but it's a tall order. And on top of that, we haven't even discussed that this is all pretty cutting edge stuff. So, in Bitcoin terms, something like BLS signatures are already something where people say ooh, well, that's kind of crazy. While a BLS signature is really super tame compared to what we're talking about here. So it is, that's also sort of my secondary concern, where it's in order to make a change like this, you need to get the entire Bitcoin community to get on board. And I'm not saying that from there are certain things that I would like to see, but I just think about okay, well, is that ever going to be something that can be pushed through as a soft fork? Because soft forks require this type of momentum where everybody's for it and everybody actually wants it, and nobody has any objections. And then I think about what we're discussing here, and I just think, well, we're nowhere near that. So it's also just sort of this impossibility of getting there. And I don't like, you can criticize Bitcoin for that. You can say like, oh, Bitcoiners bad. They need to be more, less conservative. But that's not, it's sort of just how the system is. And you can't force people to change their mind on that. So it's sort of like, it's sort of a wall you walk into, I feel.
I think Bitcoin is like Missouri. It's the show me state, right? So in order to get the momentum you're describing, there has to be some kind of intermediate app that has enough volume. Like Zigzag on StarkNet is going to do $1 tickets fees, and they may airdrop a token and vote to make it a basis point or whatever. But still, we're talking about potentially the volume in the financial side of all of this being big. We're talking about something I've been talking about for a long time is the main chain capturing more of the revenue from the exchange industry, right? And right now, Bitcoin, we could talk about, well, hey, what if we did SegWit 2x because we have Schnorr now and there's no worry. Like, I'm not saying that, but I'm just being facetious to make the point that if you did, it would be maybe technically okay, but where's the demand? We're not filling the blocks with 1 megabyte. And I'm not complaining about low fees, but we need to have a fee market. There's all this revenue, actual revenue being generated from all this trading, and also there's the hype cycle and all the Ponzi's and things which mill it about. But that we don't love over here. We want to get serious finance going. But I think Bitcoin has to catch up on market share and derivatives, and also increase the percentage of that revenue that is on-chain fees. So I think this is the way to do it. You'll get people making money running L2s, for example, and spitting these things out. And if they have to settle in opportune tokens, because that's all it works, that's business, And I think Sovryn's in an interesting position to do something here as well. And then people will go, oh yeah, this, there's some trade-offs. I get a little Bitcoin yield. I take some risks. I punt around. I trend follow something more responsible, right? And then it's like, cool. People appreciate, it's cool that there's DeFi in Bitcoin. So the product market fit is something I've had VCs like question me about. Do Bitcoiners really care about DeFi? Is this maybe it's all over here and over here they don't. But I do believe we have to do something to get get the fee market alive again. We had it cooking for years. I was trying to do a stablecoin bond thing and pay out dividends on chain, and I was like dying because I do them really cheap, and they'd get out of the mempool after 2 weeks. I'd have to send it again, right? So obviously that's not great. And then what happened, right? All of those use cases and all of the associated revenues. Like you look at ETH's fee revenues. I'm ranting, excuse me, but we're talking tens of millions of dollars a day, right? And Bitcoin has to take share. So how do we do it? Permissionlessly. Then we build momentum, as I think the answer. Edan, what's you've been kind of holding out on your big vision here, and I really would love to get your radical take.
Well, a big part of what you said I agree with, which is that we have little choice but to try and prove the value of providing people with decentralized mechanisms for using their Bitcoin, as well as building an economy of tokens around Bitcoin. If we hope to introduce changes to Bitcoin, which will make it possible to do that more trustlessly. And so I think the strategy that you outlined, which is first we build momentum and community and economic value that is undeniable by providing products that people really want to use with Bitcoin. And then we use that as a proof point for why we should introduce changes. Now, of course, there's the problem that both you and we are encountering, which is that there's this chicken and egg problem, right? So everyone loves the idea of having these tools if they are trustlessly interactable with Bitcoin. And the only way you get them to be trustlessly interactable with Bitcoin is if people start using them before they're trustlessly interactable with Bitcoin. So that's a big challenge. It's a cultural challenge in Bitcoin, and it's a legitimate challenge. And I think it's great that you're tackling it and that we're tackling it. And I think we need to see, more parties tackling it. I think one of the cool things that might be coming out of this conversation is recognition. You and I, for example, I don't know that we've ever spoken before, but one of the things that I think is missing a little bit in Bitcoin is a shared sense of destiny, even amongst competing technologists and competing projects. I think one of the cool things that the Ethereum community managed to do is create that shared sense of destiny, right? So, sure, we're all competing against each other, but we're all on the same team ultimately to try and build the world computer or whatever. And I think we're all on the same team in terms of trying to build a world around Bitcoin. And the only way I think that we do that is if we can eliminate third parties or the requirement for middlemen from other economic uses of Bitcoin, including as a payments mechanism or a reserve asset, which interacts with other types of tokens, because ultimately there are many, many different types of asset classes in the world. So if you want to build a economy or a world around Bitcoin, if you want to get to hyper Bitcoinization without breaking what I think is the most important thing about Bitcoin, which is that you have a reliable system where you don't need middlemen, then we need to have these other types of assets, which means tokens or NFTs or financial products being able to interact trustlessly with Bitcoin. So I think one takeaway is we need to figure out a way to have that shared sense of destiny. The other part of it is, there's a big aspect in Bitcoin of there's like a purity test. Like, is what you're doing really Bitcoin? And that's a difficult bar to pass because it's not entirely clear what really Bitcoin means. So, for example, I know that Ruben and myself, we both have our reservations, let's call them, around stacks. But in many ways, stacks have been very, very successful in terms of building a developer community who are, at least in their own opinion, Bitcoin focused. And so there's a real, I think we find ourselves there also on the horns of a dilemma. And one reason why I think that this topic is really interesting to me is because I think one of the escape hatches potentially from this dilemma, which could help us solve questions around privacy of Bitcoin transactions, making sure that we have enough fee generated to keep mining secure even once the subsidy goes, and the ability to build a system interacting trustlessly with Bitcoin, is for us to have a more secure two-way peg, effectively a cryptographically secure two-way peg. And I don't care about scaling, I don't care about privacy, I don't care about any of those other things, right? It could be the least efficient system, so long as you have what is effectively a cryptographically trustless peg, and it could be extremely inefficient. That's fine, because you can then start moving the funds through relays or Lightning Network or whatever. But what it does is it provides you with sort of like a portal, or a way of creating portals from Bitcoin to other systems like sidechains, where you have the pegged Bitcoin interacting trustlessly in all kinds of ways, which we can't even imagine right now. And so my sense is I want to try and help build enough popular support and find a path to a cryptographically trustless peg, which enough people could be comfortable with, because I think that if we can do that, we get a huge amount of leverage out of it potentially.
So it's kind of interesting, but So one of the things I'm thinking is that the perfect decentralized two-way peg is sort of the kind of thing that doesn't really exist, right? And I think maybe like one of the things that I don't know, Yago, if that's what you had in mind, but you're saying like, okay, well, it doesn't have to be perfect, it doesn't have to be that scalable. So you could say that these ZK rollups are like that, right? Where you just put them on the Bitcoin blockchain, and okay, they're not scalable, but at least you have this separate system where now you can do all these things. But the way I see that is that is very similar to just adding advanced smart contracts to Bitcoin and doing it all on the main chain, and then having all these token use cases on the main chain. And maybe there's a bit more separation there in terms of having separate, like John was saying, having separate UTXO sets or whatever it is that you use. So maybe one of them has a super large state, but it doesn't really affect the other. But you are, at least in that system, you are still sort of tying it to the main chain in a way that is, I think, uncomfortable. But maybe that's not what you mean, Yago. Maybe you really.
What do you mean uncomfortable?
Yeah, I was going to ask the same thing. What makes you uncomfortable about it?
Yeah, so what makes me uncomfortable about it is that really, so the ZK rollup, it really is a chain that is completely validated by all the main chain users. So whatever is happening there, it is all being carried and being done by whoever's on the main chain. So it's going to affect the main chain in a quite significant way. And one, I think, sort of like hilarious, simple example is, well, what if we had one ZK rollup in Bitcoin and that ZK rollup was Ethereum? What do you think would have happened to Bitcoin if that was the case? And I think the result would have been a massive, I mean, it would have been interesting and something completely different, but it wouldn't be Bitcoin. And so, obviously this is sort of a ridiculous example, but my point is that it is, that sort of makes it clear, at least to me, that there is an overflow there in sort of what happens on this ZK rollup will be affecting the main chain.
Ruben, I think miners would have loved if Ethereum had been a ZK rollup, making $10 million a day, whatever.
Yeah.
Funnily enough, Vitalik Buterin was in the Mastercoin scene before he was just like, all right, let's go raise some money and do our own thing. So, I mean, this is a theoretical alternative history, and we certainly wouldn't want there to be any hard fork changes to Bitcoin that play favorites to particular technology companies' vested interests, right? And so, some people maybe allege that of Blockstream. I don't. I think Taproot was pretty elegant and nobody had a problem with it, right? So I think this will come around to being that once there's enough traction, basically. But yeah, I just thought I'd share that little story.
I want to come back to one of the key things that I think you said, and I want to try and understand what you mean by it better. You say if we had this ZK rollup / sidechain, everyone on main chain would need to validate it. And I think that the entire point is that they wouldn't. Only those who were utilizing the rollup / main chain / sidechain would need to know anything about it until such time as sort of Bitcoin was pegged out of it and back into main chain. So yeah. Why do we disagree on this?
Yeah. So the reason we disagree on this is that. So okay, imagine you had a system where it was just like an extension block, right? Where all the data was just put onto the Bitcoin blockchain, and everybody would go through all the data, verify that it's correct. And then, okay, everybody's happy. And so in that case, you would agree with me that it would be a cost to all the main chain users, correct?
Yes.
Yeah. So now let's make one simple... Sorry?
Everyone that upgraded.
Everybody, yeah, that's true. Okay. But let me leave that aside if you don't mind. So now we make one change to this model where we say, okay, well, instead of putting the entire chain onto the Bitcoin blockchain, we first take all the witness data and we compress it into a snark. And what you're doing here is you're not getting rid of the fact that everybody has to validate the entire chain. No, you just change the validation model from validating the witness data to validating the snark. But the snark itself is the validation of the chain. So that doesn't fundamentally go away. And you still need to know all the rules under which that chain is being executed. You're still validating them, except you're doing it through the snark.
Okay, yeah. So what you're saying is, I need to be able to know that this snark proof was created according to the rules of its sidechain, and therefore I need to know a great deal about the sidechain. Is that what you're saying?
Well, you would be knowing all the consensus rules of that sidechain, because that is what it is to validate the snark. To validate the snark is to know whether it's valid or not, and whether it's valid or not is those consensus rules, basically. So that seems like sort of a necessary step there. Yeah, I mean, just back to my example, I guess, like, if Ethereum was that kind of chain, like, wouldn't you agree with me that would sort of have a massive effect on the main chain?
Potentially, yes. I could see a way in which it wouldn't. So let me offer a potential compromise, right? Imagine you had Ethereum, and Ethereum, but Ethereum, instead of existing as its own thing, had Bitcoin, pegged Bitcoin as its native asset, and instead of having its own set of miners, its miners were merge mining with Bitcoin, right? So what you would end up with, unquestionably, is a scenario in which all of the miners who wanted to participate, and for economic reasons it would be all of the miners, would be running both a Ethereum, or let's call it the BTC Ethereum node, or actually let's make it simpler, let's call it the Rootstock node, right? They would have to run both a Rootstock node and a Bitcoin main chain node. And so for them, there would be this huge increase in overhead. And especially if you had more than one of these chains, there would be for each new one, there would be increase of overhead for the miners. Where I think that's distinct from what you're describing is that it's only true for the miners. It's not true for users or full nodes at all.
Yeah, I agree with that. Yeah, no, but that's a different example, at least from what I'm giving, because the merged mining example is, well, okay, hold on, because so that system does not allow for a trustless two-way peg, just like how currently with RSK you don't have a trustless two-way peg. So in order for it to be a trustless two-way peg, you can't do the merged mining thing that is being done by RSK. It needs to be a chain inside of the chain that is being validated by everyone.
Well, I think what you're saying, I'm not sure I agree, and I'd like to think about it a little bit more, but what I think what you're saying is what they would do is you would create a situation where you have these ZK proofs that can be validated by the miners, but that doesn't help you because you still want them to be validated independently by every single node. Is that what you're saying?
I'm saying you if you want a trustless two-way peg, you have to validate that secondary chain, however you want to call it. Everybody has to do that. Otherwise, you won't have a trustless two-way peg. So your example where only the miners have to even see that secondary chain, that would not be sufficient to have a trustless two-way peg.
Ruben, do you consider the Zendu protocol to be a trustless two-way peg?
That's an interesting one. I would say yes. I'd say yes, it is.
And is that because of the bit field that they're putting onto the main chain, or is that not the only reason, or is that not even?
Yeah, it's the bit field plus the challenge response protocol. I think that's sort of fragile, and I think consensus is slow because of it. But I do think you end up with a working system that is trustless. Yeah.
So I think it's fair to say that whoever nails two-way peg is going to capture most of what market demand there is for like hardcore Bitcoiners who want to do DeFi things, but they have a very low tolerance for liquidity or like credit risk types, you know.
I don't think that's true, and I think the reason it isn't true is because whoever nails it, so to speak, right, would be doing so in public, right? It would have to be open source.
Sure.
It would have to be public domain. So whoever nails it will be providing a huge amount of value, but I struggle to see how they would capture that value necessarily.
Well, it's just like that. Then you get down to user acquisition, retention, monetization, right? And liquidity and, commercial stuff, basically. And that was like my analysis when I was looking at the the efficiencies rather of, or rather you could say the coefficient of cost to value footprint of like the different, like for instance, Zero Protocol and Polygon has a slight optimization over the StarkNet approach, because they innovated on the underlying recursive proofing model, and it's like maybe instead of a 20-odd kilobyte thing costing like $1,000 on Ethereum, it would cost maybe like $250 or something, right? So there's like some base hits there, right? And so then they're going to win because they have better tech. Well, not necessarily, right? Like when you get down to that zone where they're still within the same kind of ballpark. And yeah, of course, everyone wants a better cost of goods sold, profit margin, right? And that's essentially what that is. But I do think we get to a threshold where it just becomes about user acquisition, which is a little maybe cynical. And it's not all about what's platonically the best thing, unfortunately, right? Look at Luna. It was topical, right?
Well, eventually it turned out to be important.
Yeah.
So I do have a question on this kind of this two-way peg thing. Like a couple days ago when we posted this kind of like this claim that Stacks solved the Bitcoin two-way peg and the right to Bitcoin issue, and we've kind of alluded around that, I think, on this call a little bit. Like, are people familiar with that? Do they have any insight? Like, what's going on there?
My best take is that my intuitive appreciation of Stacks is that this would be great if I can not only read Bitcoin to prompt a contract's logic, but I can write to Bitcoin. And even if it's not totally perfect, because it's not as inline as like a smart contract executing on Ethereum, you can move things around, but they usually have incipient addresses, and there are these weird key central points of failure. So that's kind of common. So anyway, I'm like rambling a little bit. But yeah, I believe that they will have a library where you can then make your contracts do things such as build a transaction and publish it. So that's potentially interesting, right? So then you'd be able to tap into a multisig that's governed by this code.
Yeah. So sorry, I disconnected earlier, but I think I got the gist of the conversation. So the Stacks model, it's extra interesting because my current work on space chains is actually very closely related to what Stacks is doing, except it's doing the same thing without the altcoin. And sort of like related to the conversation that what Yago was saying earlier, like I think one viable path in which we can get more of these interesting use cases to Bitcoin is via something like what Stacks is doing, except without the altcoin. And that is basically what my Space Chains proposal is about. It is basically a way to do blind merge mining specifically in the Bitcoin blockchain. And then you create a secondary chain. And on that secondary chain, you then issue one-way peg Bitcoins. So whenever you destroy a Bitcoin, you get a space coin. And so now you have this secondary chain with these tokens that are not quite Bitcoin, right? Because you destroyed a Bitcoin in order to get there and you're never going to go back. But that token is only there basically for whatever use case is on that chain. So if you have an NFT on there and you want to move that NFT, well, you need some kind of token to pay for fees. And that is what those tokens are going to be. And because it's burning a Bitcoin, and you can always do that, you can always burn a Bitcoin, you can always move over from the Bitcoin blockchain to the space chain, but you can't go back, at least not without trading. It creates this token that is not an altcoin. It's fundamentally not going to be worth as much as Bitcoin. So it's not competing with Bitcoin. So you can have a chain that is like Stacks, but it's not a competitor. It's not this token where people can invest into it and then hope it goes up and make a ton of money. And so I think that has the potential to sort of have something like what Stacks is doing, but have it be embraced by the Bitcoin community because it fundamentally cannot compete. And then, even with that model, I just want to point out, because like one of the things that Stacks was claiming is that you can somehow then create a two-way peg on there. And that is just fundamentally not possible. The only thing you can do is you can be aware on the secondary chain, you can be aware of what happens on the Bitcoin blockchain. So you could have a contract that says, okay, well, I will only send this NFT to Bob if Bob creates a Bitcoin transaction and sends me 1 Bitcoin. You can do something like that because the secondary chain can be aware of what happens on the primary chain. But the other way around isn't true. So because of that, you can't really do something that, other than incentivizing someone to do something on the Bitcoin blockchain, there's no way you can make anything move. And so fundamentally, it won't be a two-way peg.
Well, yeah, that's what Stacks does, right? Is they bribe them with a little coin issuance.
Yeah, that's what they do. And I mean, their mining system is, in my opinion, kind of broken, because what they do is they create a blockchain and they just say like, okay, we have fees on this blockchain and we're paying all these fees back to ourselves. And it's not that hard to at least be, suspicious there. It's like, somebody creates a chain and then the fees are being paid on the chain and you're paying the fees back to yourself. So there's no proof of work or anything. Nobody is like creating anything real. And so it turns out that is actually fundamentally incompatible with Bitcoin's consensus. And what Bitcoin miners can do is they can just step in and say like, stop, I'm going to take those fees. And then essentially it will turn into Bitcoin's proof of work. So their system doesn't even function. But aside from that, I do think it's at least possible. And then my Spacians design obviously is a method where you are actually paying Bitcoin miners. So that's why it works. But yeah, that's maybe a bit of an aside.
Ruben, I'd be curious, if you don't mind, to take you back. One of the things that you agreed, and I think is really on topic for this particular conversation, is that Zendu's model would seem to create a trustless peg utilizing ZK proofs. And look, I've tied us back to ZK proofs. So I'd be curious, what would be required for you to become convinced enough about a model like that, or that model, that you would become like a chest-beating advocate for it?
Yeah. So, well, I mean, the first problem that I feel I often run into with these commercial entities that are trying to do things that even if they're cool, you try to talk to them, and I had to have very long conversations with them, and they were nice people, and they did answer my questions, but I had to really like pull the limits of the system out of them in order to figure it out. And that's sort of like this very big brick wall. And because I found it interesting, I put in quite a bit of effort, but it's like, it's very difficult to sort of really fully fundamentally understand what the limitations are. And I can't like, I understand them quite well now, but I still don't have a full picture. And so as long as I don't have a full picture, and as long as I don't get someone who has actually created that system and is actually willing to sort of help me understand these limitations in a way that's not, sort of pushing against the thing that I want to hear, I will find it very difficult to accept it. But as I understand it today, it basically replaces the non-witness data with a bit field that basically points to which outputs are being spent and which outputs are not yet being spent. And because you do that, you no longer have this problem where, so the general problem you have with a ZK rollup is that every time a new block is created, there's a new accumulator, there's a new Merkle root hash in the Bitcoin blockchain, and everybody's proof data now has changed because the accumulator has changed. So if you want to prove that you're included in that latest hash, you have to have the differential. You have to know how the state changed. Otherwise, you can't prove that you're part of this new hash. And so with the bit fields, what you get is you actually, with the snark plus the bit field, it is saying that, let's say you have a simple Merkle tree with 4 entries, and then the bit field is 0001. Then it basically says, okay, the 4th entry here was spent, but the 1st, 2nd, and 3rd wasn't. So what that means is that if you go back 1 block and you show a Merkle proof that shows a proof to the 1st entry, that you know it's still valid for this new hash as well. And so you no longer run into this issue where you need to have a new proof every time there's a new accumulator. And so that's the first step. But then the second step is that you still don't have this guarantee that, okay, let's say a new output is being created. Well, then you still need to get the proof, right? You need to receive the proof at least once. If the proof changes, you no longer have a problem, but you do need to receive the proof that you actually have an output in the accumulator. And so for that latter part, they use a challenge response protocol. And that is sort of the type of thing that Plasma Cash died on, where it basically, these types of protocols are just kind of fragile. And I guess I can go into more detail, but it's kind of a tangent. So for now, I won't. And what it ends up being is that you sort of have to have these moments where, okay, if you don't receive the proof, you challenge them to give you the proof. And then they will have some time to actually give you the proof on chain. So this all has to appear on chain. And only has to happen if they're not cooperative and they don't just give you the proof. And then if they don't actually give you the proof, the entire chain halts and it reverts to the state of the last sort of challenge period. And everybody now has to forcefully sort of peg out with the proofs that hopefully are valid that they have. And yeah, I do think that theoretically works. So the challenge response protocol is one of the weak points. And the second point that I sort of want to know more about is that this bit field, I'm not sure how efficient it actually ends up being. And I'm also not entirely clear as to like what their Merkle tree looks like exactly with regards to whether it's sort of account based or UTXO based. And so those are sort of the 2 pain points where I'm thinking like, okay, well, this bit field can actually be quite big if you have this huge tree with lots of UTXOs or accounts, whatever it is. So those are sort of the pain points for me.
I think that was a fantastically lucid explanation. Even I managed to understand it. So that was very cool. Thank you.
Thank you.
I don't know how we're doing on time or what the schedule is, but I wonder if we should leave some time for audience questions.
Indeed, I was just about to segue into that, guys. Yeah, we are approaching the 2-hour mark, so I saw a few people were requesting to speak. If you want to go ahead again and request to speak if you have any questions, please do so. Stratum is available here. Stratum, you can go ahead while people are formulating their questions. Go ahead, Stratum.
Oh, cool. Yeah, I guess my question was, I think there was a comment earlier about the fact that, at some point this would have to be interacting with Bitcoin before people actually trusted it. So in terms of routes that would be taken for a testnet, would people see it more likely that this goes to something like Litecoin, or would something like Chia potentially be in the mix, who I believe is actually beginning to experiment with some of these proofs? Like, would Chia be close enough to Bitcoin for that to give the community some level of comfort?
I think that there are a couple of different routes. One is the altcoin route. And so like Zcash, I think, was the first altcoin to like put zero knowledge proofs into production at scale. And other altcoins followed either with similar or quite different systems. Ethereum, we talked about a few times, has a bunch of different proof systems. So we can see how these things are working in production on altcoins. If we want to bring those things closer to Bitcoin, there's of course, Bitcoin testnet, but if you want to get some skin in the game, you can do it on like a Bitcoin sidechain. Liquid has bulletproofs, or not bulletproof. They don't have bulletproofs yet, I don't think, but they do have confidential transactions, which is using a kind of zero knowledge proof. RSK supports all of the same zero knowledge proofs as Ethereum does. I don't think anyone's actually like doing zero knowledge stuff in production on RSK yet, but there's nothing stopping them from doing so. And so with that, you could kind of start using your Bitcoin on the sidechain to interact with zero knowledge proof systems and get a feel for it. So yeah, I think there are a few different ways that we can start to kind of battle test these things and build confidence in them.
Yeah. So one thing to add there is that currently what we're seeing with OpsCTV is that there's been a deployment on SyncNet, which is basically testnet. Although I also agree with John's point that you're not battle testing with real coins, which is sort of a problem. And I also think so. My space chains proposal is actually a very good place for that, where you can very simply create these chains that do have real value, even though it's low value probably. So that would be sort of a second place where you could do this testing. And I do want to sort of emphasize that something like Chia or just any kind of altcoin that doesn't look even remotely like Bitcoin is probably not going to be a good example. I think you would want something to be very closely like Bitcoin, such as Litecoin, right? Where Litecoin is very similar. I think that would be probably a better place to do it.
Imagine trying to do a campaign to get a new code into Litecoin and just you're not like trying to do it for Bitcoin. So you still have to get miners to like it, right? And you still have to get the Litecoin community to like it, and that is like a much more. The whole point of the Litecoin community is they're kind of they're like moderates, right? So they're like easier to please. Litecoin hasn't performed very well. So there's a lot of hope that this appeals to instead of being seen as evil or something. Yeah.
Well, I think the Litecoin mining community is increasingly the Dogecoin mining community, or what thought they were going to be the Dogecoin mining community. So
technically, Litecoin is a testnet for Dogecoin, and Dogecoin is the testnet, then the testnet for Bitcoin. Right, yeah.
I think there's a lot of script up for sale right now.
Unfortunately, the Dogecoin repo has a lot of technical debt that needs to be caught up on. So, but theoretically, that could be the case. Also, Elon is like a community leader. It hasn't gone great, I guess, but hey, he's buying this website, so maybe maybe he'll lean into it, and that could give some user acquisition edge. And then those people, having grown up again on ZK souped up UTXO money with Doge, would then become Bitcoin, not necessarily maximalist, but they're gonna appreciate what Bitcoin is for. That would be that's my kind of middle of the road liberal take that still respects what King Corn stands for.
Yeah, I think that's actually a great take. I agree.
Thank you.
Go ahead. You can unmute yourself.
Okay, Ruben, a while ago you said that if we were to add a Snark to the Bitcoin consensus rules, the rules will also have to know about the specific consensus rules of the sidechain. Is there a way? I worry that this might mean that every time we want to add like a new sidechain, we will have to change consensus rules on Bitcoin. Is there a way to agree on a simple general Snark and a simple way to encode like the payouts so that we can do just one consensus change and introduce a Snark?
Yeah, so the thing that you need is a general smart contracting language that can express all the rules of the sidechain, and you could have that smart contracting language also express the Snark itself. So I think that's sort of like the thinking that I have is that what you really want is to have sufficiently advanced smart contracts that you can do all those things, and then it's sort of like how Ethereum works today, basically, right? Where you just have this smart contracting layer one, and then because you have that, you can express these layer twos inside of it. And I think that is fundamentally sort of how you would need to do it for Bitcoin as well. And I think that's sort of exactly the tricky complexity that people sort of miss when they talk about this, right? Where there's like, oh, let's just implement Snarks and then we have all these things. And it's not quite like that. You need to have this entire language. And there are some languages like that, like Cairo is one for Starks. So there's definitely some interesting areas there, but it's not a conservative change.
Okay, so what you are saying is that Bitcoin script itself should have like a lot more of codes and be general purpose so that it can encode like general purpose Snarks, flexible Snarks. But what if we just like decide on a very simple like virtual machine and directly code that into C++. And there's only like one type of a snark. And then because it's general purpose, it can be an interpreter for other kind of sidechain rules, something like that.
Yeah, I mean, what you're describing is a advanced smart contracting language. Like that's ultimately what it is, right? Because if you are able to create these general rule sets and have them be interpreted by the snark, well, then that's what you have. You have this programming language, right, that you're building into Bitcoin, and that is just fundamentally not simple. And okay I guess maybe one thing to add there is that there are sort of naive and simple ways to do it, but that's not the way we do things in Bitcoin, right? Where like I think that's very much what happened with Ethereum, where it's like, oh yeah, let's just do it. It's simple. Let's just add JavaScript to a blockchain, and there we go. And it works, but you have all these secondary issues.
I was wondering about if there's a way without exposing of that generality on new opcodes.
Yeah,
I know that it's like also a big change to consensus because it's a lot of C++ code on core or whatever client that needs to be like it's part of consensus, but maybe like a fourth interpreter or something that is like minimalistic but general and could be an interpreter for more complicated stuff.
Yeah, so one point you're making there, which is true, is that you can at least separate those two out, right? Where you say, okay, we have this advanced smart contracting language, but it's only for the ZK rollups. Nowhere else in Bitcoin can it be used. That is definitely something you can do. I don't think that would make it any less controversial. And in general, I would recommend you look into simplicity, because I think simplicity is very much just this idea of like, let's do advanced smart contracts for Bitcoin, but let's do it right. And that should also allow for things like actually building the entire Stark framework and turn it into an opcode or a jet, as it's called, inside of the simplicity framework. That would all theoretically be possible. So I have some moderate hopes that will be a good way of doing it. But it's still early, and it's that in itself is also pretty complex. So it's just a hope as of this moment. But it's an interesting one.
I just want to mention that. So the way that the Zendu protocol works is that it kind of calls itself a decoupled sidechain protocol, where the sidechains can actually have any kind of arbitrary rule set, and the main chain full nodes don't have to know like they don't have to like run a full node of the sidechain or anything like that. They can use the proof verification. They call it a universal proof verification system that's been set up on the main chain to verify the withdrawals from the sidechain, kind of regardless of what the rules of the sidechain are. So I would suggest taking a look at what they're doing to see if your assertion that that the main chain full nodes need to know all the rules of the sidechain is actually true.
Yeah. So that sort of goes into, I think, the thing I talked about with Yago earlier, where the validation of the snark is the rules of the sidechain. Like that is what it is to validate the snark. Like so that is where that comes into play. And so that's
I'm not sure if that's true though. Because it is a zero knowledge proof. So what you have is the data availability missing piece. Like for instance, if it's a peg out and it evaluates as true or false, and there's a corresponding data that you may or may not have that you can then checksum against that, and that so that's like sort of the hint. That's the privileged input, and so you can verify it through the low degrees testing or other. Usually, it's these polynomial low degree tests that these protocols all use. You don't need to know everything about, the smart contracts that people were trading and things like that. You just need to have like a blob of JSON. That's maybe the equivalent, or not even a blob of JSON, maybe that's the equivalent of like a big batch settlement, almost like the way an exchange does withdrawals, right? Maybe even using SegWit. And I think we would need a low-level opcode that can go from A to B to get like the perfect thing.
Yeah, I don't quite think that gets to the heart of it, because yes, so that sort of goes back to the witness data, right? That you don't need the witness data in order to validate it, and that's going to be in zero knowledge. Yes, I agree with that. But if you have a snark that proves, let's say, a chess match, or you have a snark that proves a Go match, for instance, let's say, then you need to, before you even can validate the snark, you need to know the rules of the chess game, and you need to know the rules of the Go game, and that is what you are going to be validating the snark against. So that's construction of the rules and the agreement on what the rules are that the snark is validating. That part still needs to be validated by the main chain.
Maybe it's kind of like analogous to the difference between a full node and an archival node, where having all the data and being able to run through a proven snark and then be like, yes, that all makes sense is one thing, but maybe that it doesn't have to apply to everybody. Maybe it's just the on-chain consensus is that here's a transaction that is pushed by a proof checksum the same way that a script sig has a validate signature, whatnot. So I think maybe it's better than what you're saying, but I'm not smart enough to make a highly detailed argument to go either way in this conversation.
Yeah. Well, if I am wrong, I'd love to learn about it. So please tweet at me or DM me if you have some documents I can read about that. But that is at least how I understand it currently.
Well, I'll definitely send you this thing I've been writing about the ZKs, and we can chat about that. But yeah, I mean, we'd all like to sort of, this is why we can't have nice things, right? Is because it's a trade-off, and what's the right trade-off? And we don't have governance in Bitcoin. There's no voting, right? And that's kind of a win. It's like very libertarian. It's very minimal principles, and the kind of things that are likely to get community. What technical consensus is vaguely defined, but let's say it exists and is a real thing, and we can kind of know it when we see it, and it'll tend to be things that are more elegant, which I think is healthy, right? I think we'd all agree there, rather than things that are baroque or have weird asymmetries or can introduce, like you were using with your extension blocks analogy. It's kind of a good one. Yeah.
So Patrick, there's actually something that, I mean, so, I feel like you've kind of been all over the place during this conversation, and it's all very interesting what you're saying. But what's funny is that you didn't really talk much about one thing that I am actually interested in, that as far as I understand, you are actually working on, which is StarkSync. So just to sort of summarize, like, I think one of the things we haven't really touched on that much is sort of these examples of, okay, so we talked a lot about the ZK rollups and how to sort of do it if you had some kind of soft fork. But there's actually a few things you can do with Snarks without a soft fork, and one of them is to basically speed up the validation of the history of the Bitcoin blockchain. And so that's, I think, a really cool project where, I talked to some of the Stark people as well. And so Patrick, you're working on this. And so the idea is that you can take all the history of the Bitcoin blockchain, and instead of downloading all of it, you just take, I guess, all the headers, so all the proof of work headers, those hashes, and you take a single UTXO set, and you take a snark, and with that you validate that the UTXO set that you have is actually correct. And it basically allows you to skip IBD, or IBD is what we call the initial syncing of your full node, and make that potentially a lot faster. So I'd love to hear you say a few things about that, Patrick.
Awesome. Yeah. So, in order to get it done, basically what you have to do is go through all the C++ functions for different chunks, and also think about, kind of the mathematical, right? So you've got a block header, there's like an embedded notion of difficulty and timing in that. And, there's the script functions that you're analyzing when the Bitcoin client, says this is a valid signature and relays it. And so we're kind of chipping away at these one at a time. And this first grant we're doing, we were going to go for the whole enchilada. We like talked it down to finishing up with some SPV header instead of a full history. But then what we want to accomplish is what you just described, where if you have all that data, as a full node, you'll be able to run this code and you'll be able to the final version and generate this proof. And then, you mentioned with the UTXO set, which is kind of big, right? It's about 4 GB. So I'm wondering if there's a way to, because like you can also have proofs of all the state transitions, and then proofs are recursive, right? So you can write code to generate a proof, and it can be an input into some more code, and on, right? And that's really cool. So you can kind of slice and dice it, every little bit of logic, right? But yeah, we're as a world where you have full nodes generating these proofs, and light full nodes, because it still has this. It's different from like SPV node that people have talked about for a long time, where you'll take some risks on zero conf payments, right? We're not really big fans of that because we don't love game theory murder holes for the money, right?
Honest majority minor assumption, but yeah,
exactly. Is that not a game theory murder hole, right? But thank you for elucidating what I'm specifically meaning by that. I believe we'll have a world where people will be able to have a Bitcoin full node on their phone, and that opens up a lot of cool stuff. And also the residual, if you got a little hardware, the residual income potential, the recursive proofing for it is another bit of work, right? So we're going to open source all this stuff. It's going to be in Cairo. You can use Cairo for more than just writing ETH-L2 apps is a nice chestnut of wisdom.
Cairo is open source though.
Cairo. So the thing is, it uses the shared prover, which is, and it's open source. I believe, they have a Rust compiler. They got Wormhole, which transcompiles from Solidity. They got a lot of stuff, and it's all open source. It's under license. And their business model is you have to use their prover if you're going to use this under the license. But they are going to open source their prover.
Look, I mean, I think it's also like because this is kind of the type of permissionless change, right? Where you're not changing anything about Bitcoin consensus. You're just applying this technology to the Bitcoin's history. And then anyone who thinks that's good enough, even if it isn't open source, like I personally think that's not a problem. Like obviously, if it's all open source, I mean that would be better. But regardless of that, it is cool that it's possible, and undoubtedly, like this stuff will only get better, and it'll. I'm sure it'll all be open source eventually. But I don't think your argument even needs that. Like the fact that you can get and from what I hear you say, you're not quite there yet, but okay. At least theoretically, you can actually validate the entire history of the Bitcoin blockchain and know that what you have is correct without having to download every individual block. I mean, that is already potentially really awesome. And this was actually something that talking to Lewis from Stark, he messaged me about this, and because I thought like, oh, this is still far future stuff. It's not going to be possible yet. And he was like, oh, actually, I think we can do it. So that's something I'm really excited about. And then, the second thing is, you mentioned, you asked me about U3XO. So you don't actually even have to download if you had U3XO as well, you wouldn't even have to download the UTXO set. You would just download a hash of the UTXO set, and that will be enough to get you at the tip. And then you could continue to validate new blocks coming in from that point. If you had the whole U3XO, protocol running, which isn't done yet, but theoretically this is all possible and really cool.
Oh, I'd love, I just saw the repo recently, and I definitely think it would fit into where I'd like to be in like a year with this, where you just have like a 100 megabytes, depending on how much of because I feel like there are some, so this is what I was saying about LevelDB. There are RPC calls, and I'm very sensitive to this because with OmniLayer, you super depend on like re-indexing and putting stuff in LevelDB about what's going on, about state. And that kind of is annoying, right? So there may be some things that you need naive replay of recent blocks to collate, but then you just proof those again, right? So it can become a bit like Mina, where maybe it's not like a strict assembly line, transaction for transaction. The way I mean is there's a little buffer, but yeah, this is where we're going. And that means when you combine this like mesh nets and stuff, that we can have like a sovereign internet of money that like 2 billion users can really use. And I'm happy with that.
Yeah. So, I mean, I am a little skeptical of the light client claim though, because yes, you'll be at the tip, but then if you want to continue from there, you still have to download full blocks, right? So that's still pretty heavy.
Node and stuff do that well in JavaScript. You just would need the footprint, right? So yeah, I think with a phone card space or SD card space, you can bladder it, and then there's like more engineering work to be done in that nuance.
Yeah, well, I'm mainly concerned about the bandwidth there, but it is definitely a lot better than where we are today. And either way, it's really cool that it's possible. So yeah, I'm excited about that. So there's one thing, a bit of a tangent, but I got one more question on Twitter about whether Snarks can apply to RGB or Taro. And I think that's sort of an interesting one too, because initially I thought like, oh, that's going to be difficult. But after having a few conversations with a few people, I think it's actually pretty viable because. So I don't know how familiar people are with RGB or Taro, but basically the way it works is that you it's similar to these op return things that we've been talking about, where you put an op return on the Bitcoin blockchain and then you have some other software that interprets those op returns as colored coins. But in this case, you're actually sort of hiding those op returns inside of public keys on the Bitcoin blockchain, so they're not immediately visible. But anyone can sort of go and show you the commitments, open up the commitments, and prove to you that they actually have an NFT or whatever the color coin is. And the downside of this system is that because the proofs are not public, but they have to be revealed to you, you actually, when you're transferring over the NFT, you have to reveal the entire history of the NFT. And so you have to open up all the commitments and show that, yes, Alice created the NFT, then sent it to Bob, then sent it to Carol, and now me, Carol, is sending it to you, Dave. And that is sort of like how you do it. And that in itself is also something that would be, I think, very well suited for Snarks, because what you can do is with every transfer, you take, you prove the history of the Snark, and then the final transition, you can make it recursive, right? So Alice makes a proof, then okay, let me see. Sorry, I'm not explaining this very clearly, but okay, let's say
but you're talking about Carol? Taro, right? This is a Taro explainer.
Yes,
that's a good one. What is another kind of dumb, smart way of summarizing it to say that it's like leafing, it's putting op return type payloads in the Merkle tree of a taproot.
Yeah, it doesn't really matter where you put it, but yes, that would be one place to put it. And but you're doing that, and you also, like, the main point here is that you have to reveal the entire history whenever you make a transfer, because the history is not publicly available. And so what I was saying is that, let's say you have a Snark that proves the transfer from Alice to Bob to Carol, and now you want to send it to Dave. What you do is you take the Alice, Bob, Carol Snark, and you take the transition, and you snark those together, and that becomes your new Snark. So every transition, you take the old Snark plus the transition, and every client peer-to-peer updates the Snark and sends it to the next person. And that way, the state doesn't grow, basically, because every time you just take the old Snark plus the transition.
Oh, so you have like a verifier embedded in your client. Taro is, until you're publishing things on chain, it's all constructive to scripts that are interlocking with, well, maybe. So like, just to delineate, like OmniBolt does this thing where they have an op return in the updated Omni layer they published. And then from henceforth, we deem this UTXO 100 tethers, and then it can bip around Lightning Network. And then Taro is like a more efficient way of collating that kind of stuff. Is that fair? And then, but it has this problem. So if you added a Snark And this would be definitely like a concise snark, right? Because we're talking about very limited canonical data that's getting crunched on here. So snark's really appropriate for this particular use case. Yeah, I mean, it's cool. And I mean, it's probably smarter than routing a bunch of Tether UTXOs around the Lightning Network in the like 2019 era Lightning routing type model, right?
Well, yeah. I mean, the main problem you get is just that this state can actually grow until it's the size of an entire blockchain. And so what you do here is just with every transfer, you sort of update the snark to add the new transfer. And so all like everybody individually doesn't have to do a whole lot of work. And everybody just does a piece. Every time you transfer it, you sort of update it.
Is this the first time anybody's talked about improving Taro with snarks?
I think the idea has been like sort of circling around, but I don't think anyone has concretely like put it into words like this.
Well, folks, you heard it here first.
I guess so.
Yeah. So basically TLDR is that, yes, like so if you could make a verifier push tokens on chain in like a single batch transaction, right? So for example, if I pay a dividend in OmniLayer, a bunch of Tether, right? Or I do it or I have a derivative settlement every block in TradeLayer, there isn't like a send to like update balances, right? It just boop, it's like the logic, here's the new state, and this is the consensus, right? So it's actually kind of elegant. There's things sort of left to the imagination that aren't all on-chain data. So Taro creates a lot of advantages because it combined with Taproot and create all these efficiencies, except for this asymmetry that you're describing. So we can improve that. Then, yeah, you could like soup together kind of like what John Carvalho's done with like multisig. So people are sharing that. And then they have all these assets, and whether they have like LN channels or like with tokens, you can do LN type movements without the routing because tokens do what the fuck you want instead of being like a Lego Tinker Toy of a bunch of old scripts from like 2013 or 2010, right? So anyway, I see a lot of composability there, and I think it's very cool. And it's bigger. It's like what I've done maybe can add to that because I've taken the Tether soup type thing, and now I'm trying to do like decentralized Tether within that. But it's like shitcoin. It's powered by shitcoin speculation, and that's just what it is. So it's appropriate language for this audience. And that's a trade-off. And then, people can fork that, and it'd be nice if there was like a soft spoon for the existing people, because, we did like build this thing. It took a lot of money. But, okay, it's like open source, and I don't sue people, it's like I'm over it. And anyway, these tools will blend together in potentially beautiful ways. So don't give up on Bitcoin as being Stone Age tech, guys. It's got a lot of potential. And when it comes out, it won't be like a Dragon Ball Z villain, which is like gone through all these transformations like Cell or something. And it's this monstrosity. Is this a good analogy? It'll be like Goku. It'll be lean and mean and sort of pure of heart, but it has transformed into a super Bitcoin protocol, essentially. So I mean, for me, that, unless there's any more questions, that would be my closing statement. I don't think I can top Goku.
Yeah, I don't know if I think we lost Yago, so I don't know if there's anyone who can actually like take questions at this point. Is there is the sovereign person available, or?
You bet. And
okay.
Yeah, I mean, we don't have any more questions at this point, so we can.
Okay, so there are no more questions. Okay.
Yeah.
Okay.
Thank you to you both for joining us, and to John Light. It's been a very fascinating space. We might have to do 2 recordings of this because it was so long, actually. So yeah, but
nice.
Good feedback on Discord. Be sure to follow them, guys. But Patrick, Dugan, Ruben, Somsen, both of them. Also, if you're liking the type of content you're hearing, follow us at Sovryn BTC. Thank you to all our guests, and of course, John Light at Litecoin. And yeah, thank you very much, everyone. Don't forget, stay sovereign. Cheers, guys. Thank you to our guests.
I had a great time.
Yeah, thanks. And please, if you guys are interested, check out my Space Chains work. I think it's sort of a viable way to get some of these changes into Bitcoin without actually needing any changes to Bitcoin, which is, I think, sort of probably the easier way to get changes done than trying to get a soft fork.
You bet. All right, we'll put a link to that on the recording.
Cool.
Thanks, guys. Stay sovereign. Bye.
Yep.